This one says two resistors of 496 ohms and 607 ohms are going to be in a circuit with a capacitor of 2.75 microfarads. The inductor has an inductance of 6.3 millihenries. The branches are in parallel with a source where the source is 92 volts RMS. We want to determine the RMS current from the source for very large frequencies. Alright, so one thing we have to know about capacitors and inductors is that when the frequency gets very large, they're going to tend to either block all current or they would let current through totally. So they're opposites, right? So the one that lets current through at large frequencies is the capacitor. When the frequency F goes toward infinity, the reactance of the capacitor goes toward 0. That's something we had looked at before when it came to capacitors. There's a formula that tells that. The formula is that the capacitive reactance is 1 over 2 pi Fc. So clearly, if the frequency were to become infinity, you'd be dividing by infinity, and then Xc would go towards 0. So if that happens, that opens up that branch for current to flow. So current will flow here. But what about the other branch? When frequency goes toward infinity, inductive reactance goes toward infinity as well. Now, why should this be the case? Because of the formula XL equals 2 pi FL. So clearly, if F were to go toward infinity, then XL would go toward infinity as well. So that means that in this middle branch, no current can flow. But that's only at large frequencies. And the reasoning for why is because, see, inductors, they don't like their current changing. They resist changes to the current. And the more the source oscillates back and forth, the more reactance there will be. But now we can actually solve it. If they want to know the RMS current, we figure, okay, we've got a certain amount of IRMS that's going through the source. No current will flow through the middle branch. That means that whatever current we have will be going through the second top branch. Alright, so we'll use that. Alright, so our resistance is 496 ohms. And we said that the capacitive reactance would be 0. So the total impedance then becomes 496 ohms. And now for the last step, we'll solve for IRMS by dividing the RMS voltage by Z. So 92 volts over 496 ohms. I'm getting 0.185 amps.